Today's video takes a look at a couple clones or variants of the popular cheap yellow display. As I'll show, this is not as straightforward as many other components you might use in your Arduino or ESPHome projects. Be prepared to do a little research and a lot of trial and error, but I'll show you some tips and techniques to try with your own version of the CYD or even with clones of other types of components. Hi, and welcome to Resin Chem Tech. In a previous video, I covered the APDS9960 multi-sensor as part of a larger planned project. Well, this is another component that I also plan to use in that larger project, which I hope to share at a later date. But today's component is the cheap yellow display. And as you will see, getting this component to work was not as simple as just plugging it in. Given the amount of time and research that I had to spend to get these two different clones to work with both Arduino and ESPHome, I do want to say up front this probably isn't the best component for beginning DIYers. But as usual, be sure to check the links down in the video description, where I will provide links to more information, including a written guide that will include all my code samples, GPIO pinouts, and other things I just don't have time to cover in this video. And just a quick side note, if you did come here looking specifically for ESPHome, I do spend a lot of time during the Arduino testing identifying things like GPIO pins and the type of driver chips used that will also be needed for ESPHome. So if you jump to the ESPHome section and want to know how I found things like the GPIO pins, you might need to jump back to the start of the Arduino section, where I'm going to cover that next. In that previous component video on the APDS9960, I discovered that in my electronic pursuit of life, liberty, and happiness, that all clone boards are not created equal. So after I ordered this first version of a cheap yellow display, I noticed numerous differences from online docs and articles about the board. So in this case, I decided to go ahead and order a different version from a different seller, trying to locate a version that more closely matched the online articles. And as you'll see, the differences between these clones are pretty pronounced. From the front, you can't see a lot of differences, but there are a couple. For now, I'll refer to the board here on the left as Clone A and the board here on the right as Clone B. Now, both boards have 3.5-inch displays, although you can find versions with other screen sizes, 2.8-inch being the most common. Now, Clone B has an RGB LED on the front, and as you'll see in a minute, Clone A has that LED on the back. Clone B, in addition, has an LDR, or this light-dependent resistor on the front, which can be used to read the current ambient light level. Clone A does not seem to have this feature. In terms of accessories packed with the board, Clone A has this 18-inch USB-C cable, while Clone B has a 36-inch micro USB cable. Clone A comes with this 2-pin JST connector with bare wires on the other end, while Clone B has a 4-pin JST connector with these DuPont connectors on the opposite end. Now, Clone A has a stylus and Clone B does not, but there's a reason that Clone B doesn't include a stylus. While it's not visibly obvious, the two boards use different touchscreen technologies. Clone A uses a resistive touch, while Clone B uses capacitance touch. Now, I'm not going to go into detail about the differences. I'll leave a link down in the description if you're interested. But as a general rule, capacitance touch screens are more sensitive and also support multiple touch like pinch to zoom. Resistive touch, however, can be used with gloved hands, non-conductive stylus, or really anything that can apply pressure to the screen. For my larger project, I think I'm going to want to go with capacitance touch, but I'll wait for the bench test to make a final decision. So while there aren't many visible differences on the front, the largest differences can be found when we look at the back side of the boards. First, note that here is the LED on Clone A that was also found on the front of Clone B. Now, both boards have boot and reset buttons, although they are located in different spots. Both boards also have JST connectors for serial or UART communications and an external speaker. Both also have a micro SD card slot. But that's pretty much where the similarities end. So let's look at some of the differences. The biggest difference is the fact that the two boards use different ESP32 chips. Clone A uses a standard ESP32, similar to the ESP32 W-Room you might find on an original node MCU style board. Clone B, however, uses an ESP32-S3. This provides some additional differences in overall specs for the boards. The ESP32-S3 version has slightly newer versions of the Extensa core and Bluetooth LE, and does have 4K less RAM. In this particular board, it does offer 32 meg of flash versus only 4 meg on the base ESP32 version. Also note that Clone A uses USB-C and Clone B uses micro USB. Do note that getting this information can be a little bit like pulling teeth, especially with some of these cloned components. Documentation for things like the ESPHUs, the type of LED used, GPIO pins used to connect to other components like the display, the LED, the light sensor that's available on Clone B, etc. may not be provided at all, or a link to an external site might be provided. But even then, there's no guarantee that the linked documentation matches your clone. Here, for example, is the linked documentation for that Clone B board. Already you can see some major differences. The documentation only shows a standard ESP32W room, while the clone is using an ESP32S3. In addition, even the JST breakouts in the documentation are different from what I have on my clone. But speaking of ESP pins broken out to JST connectors, that's where we'll find some of the next biggest differences between the clones. Here's a closer look at Clone A, or the normal ESP32 version. At the bottom you'll find the UART or serial connection, which consists of connections for 5 volts, ground, RX, and TX, which are GPIOs 3 and 1. Next to that is the battery connection, should you opt to power the device via battery. Now along the top are 4 additional JST connections, with the rightmost connection being labeled I2C, and it has pins for 3.3 volts, ground, and GPIOs 25 and 32. Now note that these GPIO pins are not the defaults for I2C on the ESP32, which are normally GPIOs 21 and 23, but since most ESP32 pins can be used for multiple purposes, this isn't a problem. Just note that you'll need to include the pin numbers when defining I2C in either Arduino or ESPHome, since this breakout doesn't use the defaults. Next is another 4-pin connection, and this one is labeled SPI. It includes 4 GPIO pins, 23, 19, 18, and 21. While labeled SPI, again, these pins can be defined and used for other purposes. Beside SPI is the speaker connection, and while not labeled according to the documentation, it's controlled by GPIO 26. And finally, on the far left is a 2-pin connectors for GPIO 35 and 39, which can be used for digital input. Now do note that these GPIO pins are input only, so you cannot use them to send data to or to control an external component. And of course, there are many other GPIO pins in use. For example, the display uses 6 GPIO pins. Touch uses another 5 GPIO pins. The card reader uses 4 GPIO pins. The LED uses 3. The boot button is tied to GPIO 0. I'm not going to go into the detail of all the different GPIO pins used here, but you can find all the various pin mappings in the written companion guide for this video. The last thing I want to mention here about Clone A is it does use a USB-C connection, and as printed right here on the display, it does use Resistance Touch. Clone B, or the ESP32S3 version, also contains the same UART and speaker breakouts, although they are located in different spots on the board. There are 2 additional JST 4-pin breakouts here along the bottom. The one on the right has ground, GPIOs 21, 22, and 35, and the other at JST breaks out 3.3 volts in ground along with GPIOs 21 and 22. Now note that both of these JST connections have connections for GPIOs 21 and 22, so why would you break out the same GPIO pins more than once? Well, recall that I mentioned that GPIO 21 and 22 are the defaults for I2C. And since multiple I2C devices can share the same GPIO pins for clock and data, as long as each device has a unique I2C address, this would allow you to connect 2 I2C devices to the board. And of course, like Clone A, there are GPIO pins for things like the SD card reader and the LED, which is on the front of this board. But overall, Clone B has fewer GPIO pins directly broken out to these JST headers. In fact, other than UART and the speaker, Clone B only makes 3 GPIO pins available versus 8 GPIO pins on Clone A. The Clone B does use a capacitance touchscreen and also uses a micro USB connection. So which clone you select for your project, or selecting a completely different clone altogether, will depend upon your particular project needs. Now, one final note regarding connections. Note that all of the JST connectors on both of these boards use 1.25mm JST headers. That means things like DuPont connectors aren't going to work with these boards. In addition, JST connectors like the 2.54 that you might be used to using with LEDs also is not going to work. Now, as I mentioned, both boards come with a single JST connector, 2-pin for this one and 4-pin for that one, but if you need to make multiple connections, or you need to make connections to one of the headers that have a different number of pins than the supplied cable, Then you're going to need something like this small little JST connector kit. And inside of this kit, you have different numbers of pins and different colors of wires, so you can custom build whatever cables you need to connect to the JST connectors on these boards. So while there are many similarities but also significant differences, I'm going to try a series of different bench tests on both boards using standard Arduino libraries and an ESPHome configuration to see if the boards work or respond differently. But first, according to some document sources, these boards come with some example firmware already installed. So first, let's just power up both boards for the first time and see what we get. I'll just be powering both boards with 5 volts via their respective USB ports. Okay, we can see both boards are booting up, and there does appear to be some kind of default firmware installed on here. Again, I really don't know anything about this. This is the first time I've powered these on, but let's just try some things here and see if the touch is definitely working on this. So it looks like we've got some war driving and some sniffer stuff regarding Wi-Fi on here. Okay, so that seems to be working just fine. Now this one, remember, is not capacitance, or not resistive touch, it's capacitance touch. So let's just see what happens if we touch there. Okay, that does seem to be working. So this looks like it is just some kind of sample firmware here. So it doesn't look like it's complete. We get some different colors down here. So there we go. So both boards appear to be working just fine, but of course, we're not going to want to use this default firmware. One more thing I want to quickly mention is I played around with these boards a bit more off camera, and that's the difference between the resistive and the capacitance touch. Over here with this capacitance touch, the board is very responsive and it scrolls nicely and it's very easy to use, and I don't seem to have any problems in terms of the accuracy off on this. Again, that may have to do with the firmware and not the board itself. We'll test that a little further, but also note that the stylus will not work over here on the selected option. Now, part of that might have to do with the way the firmware is written in the calibration on this, but I do have to more or less use the stylus here, and even then, like right there, it seems like the calibration is off on this. Again, that may have to do with the firmware and not the board itself. We'll test that a little further, but also note that the stylus will not work over here on the capacitance touch. So you definitely want to use resistive touch if you're going to be using something like glove fingers or a non-conductive device to be able to interact with the screen. But if you're just going to be using things like finger or touch on here, the capacitance screen definitely seems to be much more reactive and much more accurate than the resistive version. So while this demo firmware is fun to play around with and does let us know that certain features of the boards are working, you're almost certainly going to want to install your own firmware onto these. Let's start by taking a look at Arduino first, then we'll take a look at ESPHome. Before we can try out some test Arduino code on the boards, there are a few things that need to be determined. First, I need to identify the ESP chip used so I can select the proper board in the Arduino IDE. Now, Clone A seems to be pretty straightforward. The chip itself is identified as an ESP32E. This is usually an ESP32W room on dev boards and uses an ESP-DAO-D chip. And that's also what the Amazon listing shows, along with a total of 4 meg of flash. Now, as a double check, I also connected the board to my PC and ran ESPTools, and you can see that it's also reporting the chip as an ESP32-DAO-D V3, which is what is expected. This means in the Arduino IDE, I can probably just use the ESP32 dev module, which I've successfully used with many other ESP32 dev boards using the same chip. Clone B presents a bit more of a challenge, as this isn't a standard ESPHome chip and instead is a rebranded version. All we have to go on is the model number, XH32S, and the Amazon listing, which states that this is an ESP32S3 and has 32 megabytes of flash. When I connect this board to the PC and ran ESPTool, Clone B shows the chip as an ESP32-DAO-D V3. In fact, these are the exact same specs as Clone A. And after quite a bit of searching, I even found an old spec sheet for the XH32S model number. This actually shows the Tensilica L106, which is normally used in the ESP8266. Now, this particular spec sheet is pretty dated, so it's entirely possible that the ESP was upgraded since this spec sheet was released. I do believe it's an ESP32, as reported by ESPTool, but I don't believe it's an ESP32-S3. And to verify this, I connected a standard known ESP32S3 board and ran ESPTool. And as you can see, it properly reported the ESP32S3. This pretty much affirms that Clone B isn't an ESP32S3, but just a standard ESP32. In fact, it also makes me question the advertised 32 megabytes of flash. External flash, if available, would normally be found here, but as you can see, there isn't a flash chip installed on this board. Now, I'm not an expert at tracing circuits, and I suppose the flash could be elsewhere, but somehow I'm skeptical. Breaking in here for just a minute because a little bit later in my testing, I was able to use both the custom sketch in the Arduino IDE and a dummy binary file with the ESPHome flasher to determine the actual flash size. And as suspected, the flash size is only 4 megabyte and not the advertised 32 megabyte. Even after more digging and looking at the chips on the official ESPHome site, I'm pretty sure this is an ESP32 Rover IE, where IE indicates the external antenna connection. But the actual chip is an ESP32 D32, just like Clone A. This means the specs I originally showed for the ESP32S2 aren't correct for Clone B. In fact, the two clones likely have very similar specs in terms of the ESP32 itself. And here's the problem you will often run into with these clones. I've already spent multiple hours just trying to identify the proper board selection, GPIO pins, and other specs with these two clones. This can often be the case with these kind of popular components when sold by multiple sources, especially if the seller doesn't provide the specific or even the correct specs. Luckily, since both boards appear to have very similar ESP32 chips, we should be able to hopefully use the same ESP32 dev board in Arduino. But board selection is just part one. We also need to locate and utilize the proper libraries for the board. And in case you're new to Arduino and libraries are blocks of pre-written code to provide specific functionality for certain components or features. For example, say you have two different distance sensors, an HCSR04 ultrasonic sensor and a VL53 LOX time-of-flight distance sensor. In our Arduino code, we need to include a library for communicating with each specific sensor, and these won't be the same. We need specific libraries to speak to a particular component. The HCSR04 library won't work with the VL53 LOX and vice versa. This is why I had to spend so much time trying to identify not only the type of ESP32, but also all the various components and GPIO pins in use. For example, a library for a resistive touchscreen likely won't work with a capacitance touchscreen. And of course, you don't have to use a library, and you could write all the low-level code yourself, but in most cases it makes more sense to use a pre-built library if one is available. To just use the touch and display capabilities of these boards, we'll need at least the following: a library for the display. Now, both of my boards state that they use the ST7796 driver, so any library selected must work with this particular driver. Luckily, in most cases, libraries for the ILI 9341 will also work with this driver, so hopefully I can locate a single library that works with both boards and provides the features I need for my larger project. Next, I'll need a library to handle the touchscreen functionality. In this case, since the two boards use different types of touch technology, that is if the description for Clone B touch type is to be believed. But for my initial power-up testing, I can verify that Clone A is a resistive touch and Clone B truly is capacitance touch. But this does mean I may need to use different touch libraries for the two different clones. After doing some substantial research and reading through a lot of documentation, I've decided I'm going to initially try this ESP32 display panel library by ESPHome itself. Unfortunately, I could not get that library to work reliably with either of my clones. In fact, most things I tried simply sent the ESP32 into a boot loop. So I switched to a library commonly used with these types of displays, and that's the TFT ESPI library by Bodmer. This library has support for over 90 boards and display types, along with the ability to even add your own custom configurations. And it is very well documented, with plenty of additional examples in external sites and videos, and the unique setup allows you to switch configurations for different projects, board, or display types without re-entering all the specific data like display driver or GPIO pins used. And as you can see, using this display library, I was able to get some sample code to run and display properly on both clones. Now, I won't spend time here going into the details of the configuration, but you can find that in the written guide. Interestingly enough, for just this simple display, I was able to use the same configuration file for both clones. This tells me that both displays are using the same GPIO pins for the display. Now, of course, this is just the display functionality, which is obviously important, but no sort of touch capability has been enabled yet, nor any other functionality or components like the SD card reader or the LED. And once you have that configuration set up, it's very easy just to load and try out all the different examples that come with the library. In this particular case, I loaded up an animation example just to make sure that that works. I didn't have to make any changes to the example because my configuration is set, and the same configuration again is working for animation on both Clone A and Clone B. But of course, the other most important thing that we've got to get working is touch. Since the TFT ESPI library also supports touch, I loaded up a touch calibration and test example sketch that also comes with the library. Now at this point, I'm still using the same configuration file for both boards. This top one, or Clone A, remember it is resistive touch. So if I touch these corners where indicated, it's going to jump to each corner that I'm going to touch, maybe. Corner there and a corner there. And at this point, what it's done is actually sent calibration data over to the serial port that I can then use to calibrate this touched panel. Once that's done, now you notice that I can simply touch and test and draw on the screen, and it does seem to be pretty accurate in terms of where I'm touching. I can use my finger, or I can try to, but it doesn't work near as well in this particular case as using the stylus. Clone B down here, however, remember it has the capacitance touchscreen instead of being a resistive touch. So if I try to touch up here, try to do a calibration either with my finger or with the stylus, there's simply no response. I'm obviously going to need to do something different with this clone to be able to use touch. In fact, the actual author of the TFT ESPI library stated in one of the issues that someone opened up that his library is only designed to work with resistive touch. If you need to use capacitive touch, then you're going to need to use a different library, at least for the touch functionality. Luckily, if you look closely on the back of Clone B, you can see that a GT911 is used for touch control. Now this is an I2C controller chip, and you can see the pinout here where it lists ground, the I2C data and clock pins, a reset, an initialization, and a VDD power pin as pins 1 through 6. But this doesn't tell us which GPIO pins they're connected to on the ESP32, nor does it tell us the I2C address, which we'll also need. Fortunately, one of the external documentation links for Clone B in the Amazon listing pointed to a repo that had this diagram. Now, while the ESP32 used on Clone B appears different as it's custom labeled, I was able to determine earlier that it is an ESP32 DAO D32, so hopefully the pinouts listed here are the same. The diagram shows the Capacitance Touch SCL or clock pin is GPIO 32, SDA is GPIO 33, the reset pin is connected to GPIO 25, and the interrupt pin is connected to GPIO 21. So hopefully this is going to at least give us the GPIO pins we need for that touch controller. Now that I know the custom I2C GPIO pins for my clone, I can drop them in there and set these pins at the start of this little utility, which is simply an I2C scanning utility. What it's going to do is it's going to use those pins and it's going to scan and look for any I2C devices. As you can see here, it just found one, and it gives me the I2C address of 5D. So now I know the GPIO pins and the I2C address for that touch controller. Now I tried a few different libraries for the GT911 driver, but ended up settling, at least for now, on this init GT911 library. Note that I'm still using the same TFT ESPI library for the display. But in this case, I'm using the Clone B configuration. This is the same as Clone A, except the touch components aren't enabled since they don't work with capacitance touch. But for the init GT911 library, you can see where I specified the GPIO numbers for the touch controller that we verified in the I2C scan earlier. 33 for SDA, 32 for SCL, and 25 for reset. Now I'm using a polling method here so the interrupt pin isn't used, but I am also specifying that I2C address found as hex 5D. Similar to the resistive touch example, I'm simply outputting the touch coordinates to the serial monitor, so every time I touch this, you see we get the coordinates where I'm touching the screen. But these coordinates are actually from the touch library and not from the TFT ESPI display library like they were with Clone A. And in addition to outputting the coordinates to the serial monitor, I'm also doing the same thing I did with Clone A. I'm getting the coordinates from the touch library, but I'm using the TFT ESPI library to draw a white dot wherever I touch the screen. So you see as I touch the screen here, once again, it is pretty accurate with where I'm touching, so that is working well. Now, one nice thing about capacitance touch over resistive touch is the fact that it supports multi-touch. So you can see here, I can actually use 2 fingers, and I can draw with both fingers at the same time, and all the touch is detected. That allows me to do things like pinch to zoom that I can't do with resistive touch. But do note that with Capacitance Touch, you can't use anything like a stylus. This won't work because it does require some kind of conductive surface like your finger to be able to detect any kind of touch. So the good news is I have both display and touch capabilities working on both Clone A and Clone B. And once you have your display and touch configured properly, you can easily add something like the Light and Versatile Graphics Library, or the LVGL, to easily create buttons, sliders, or even an on-screen keyboard. Now, while the library does have some built-in support for some displays, it can also be used with other display and touch libraries. In fact, at the very start of this video, I showed Clone B running an actual LVGL demo on top of or in conjunction with the display and touch controllers. Now, of course, there are other components that are on the cheap yellow display, such as the SD card reader. And if you want to implement those, you'd use the same process of first identifying any GPIO pins, any particular chips or drivers that are used, and then locating an appropriate library. Now, I'd love to show all the various options, but this video is already going to be way too long, and I do want to test both of these boards with the ESPHome. I might be able to cover some of the additional components on these boards in my larger project video, should I ever get around to that once I'm done with these individual component videos. As a quick little side note, when it comes to ESPHome, I generally use Google search to find the appropriate configuration for ESPHome, as the ESPHome website left a little bit to be desired, especially when it comes to search. But as I was literally recording this video, ESPHome rolled out a completely redesigned website. Courtesy of the Internet Archive's Wayback Machine, here's what the ESPHome site looked like just a week or so ago. But here is the brand new site. Now, this is the first time I've seen it, but I can already tell that the search works much better than the old site. In fact, I can search for my board's display driver here, which is the ST7796, and I see the best matches right at the top. If I select this top choice, which is for the ILI 9 series, which is also compatible with the ST7796, but I scroll down a little bit, it tells me that this component has been made redundant and has now been superseded by this MIPI SPI display driver. So we'll select that, and this should give us all the information we need to configure our boards for display purposes. Looking at the documentation for this display driver, we can see that it does in fact support the ST7796 driver. Now, it also does have support for a number of pre-built boards, but in this case, as I found with the Arduino testing, these generally won't work with my clones, at least not without substantial modification. So we'll stick with the generic ST7796 driver to start. So we continue down in the documentation, we see that these types of displays use the SPI bus, which will need to be defined and configured separately. To do that, and to configure the rest of the display, we'll need to know a few things about the board, specifically which GPIO pins are used. Well, how do you do that? Well, if you skipped over the Arduino portion of this video to get straight to the ESPHome configuration, well, you might need to skip back as I cover how to get that information regarding your particular clone or board in those sections. Here's a summary of the information I gathered during the Arduino testing, and I'll also need for ESPHome. A copy of this chart, by the way, can be found in the companion written guide for this video, linked down in the video description. There's a lot of other configuration information listed here, but do note this information listed right down here towards the bottom. This display driver does not support touchscreens of any type. To use touch, we'll need to configure that separately. But like with the Arduino test, let's start by just getting the display to work first, then we'll try to add touch capabilities. In ESPHome, I've created two starting shell nodes, one for each clone. Both show offline at the moment because I haven't actually flashed anything to the boards yet. And in the interest of time, I'm not going to cover the step-by-step process of setting up and flashing an ESPHome node. If you've not done this before, then you can check out this video after this one, where I cover the basics of setting up and flashing a configuration using ESPHome. But based on my Arduino testing, I suspect the display configuration will be identical for both boards. But when I get to touch, they will be different, as Clone A uses Resistive Touch and Clone B uses Capacitance Touch. Currently, the automated generated shells just contain the basic information for connecting your board to Wi-Fi, setting up the Home Assistant API integration, etc. I'll need to add the necessary components for the display to this starting shell. After a couple of hours of futzing around in ESPHome, I did manage to get both displays to start working. Now, I won't go into the details of my configuration here, I will have that in the written guide, but I am able to display some text and some basic geometric shapes, and as expected right now, the configuration file for both Clone A and Clone B are exactly the same. But I'm showing a frowny face here instead of a smiley face because you might see a problem. Notice that the display is only partially filled. All this area out here is basically just blank. It seems to be a known issue with this new display platform in ESPHome. Just about as I was to go into a long section describing all the different things I tried and the fact that the ST7796 driver just would not work with these particular displays, and if I could use the ILL9341, which works but appears to have these fixed dimensions, anytime I try to use the ST7796 or to add dimensions to the ILI9341, I would end up getting this error despite the fact that the code would compile and flash successfully. I even tried a bunch of different SPI modes to see if that might be the problem, but nothing I tried would work other than the ILL9341, and it had the limitation of being fixed dimensions. But as I was doing all of this testing, I got notification that a new version of ESPHome had just been released. And in the changelog notes for the new ESPHome 2025.8, there have been a number of updates, changes, and additions with the MIPI displays. So I decided to go ahead and upgrade to ESPHome 2025.8 and give it another shot. Lo and behold, the new release of ESPHome fixed the display resolution issue. I can now utilize the entire display. With ESPHome 2025.7.2, attempting to use the ST7796 chip compiled and flashed just fine. But it didn't work as the display did not get set up properly. Now I tried numerous options and settings, including using different SPI bus modes, but the same error always showed up in the logs when using ST7796 and the display failed to render anything. Switching to the compatible ILI9341 and adding the board dimensions resulted in the exact same issue in a log message. The only thing I got to work was using the ILI9341 without dimensions, but this limited the display to the fixed 320 by 240 dimensions, which is what I initially showed. However, with the new release of ESPHome 2025.8, I can use the actual ST7796 chip and specify the display dimensions. This worked without any errors or issues in the logs and allowed me to use the full 480 by 320 dimensions of the display. If I hadn't already spent so much time just trying to get these displays to work when all I really needed was an ESPHome upgrade, I would have taken the time to turn the frowny faces into smiley faces. But it was important that I have the board dimensions defined properly, so I can now move on and attempt to implement touch on both of these clones. Recall from the display documentation that unlike some Arduino libraries, none of the display components in ESPHome include touch. We have to configure a touchscreen component separately, but it will also use the display we've already defined. What's more, this is where Clone A is definitely going to differ from Clone B. Recall from the Arduino portion of this video, we determined that Clone A is using Resistive Touch with the XPT2046 driver, while Clone B is a Capacitance Touch and uses the GT911 chip. I'll start out with Clone A and the XPT2046. And here we can find the documentation for the XP2046 touchscreen controller. Now this isn't everything that you need, this is specific to that. We do also have to take a look at the base touchscreen configuration because you see here we have to specify the display that we've already set up. So I'm going to take this information along with the information that I gleaned on the GPIO pins from the Arduino section and see if I can get touch working with Clone A and the Resistive Touch. Here in my Clone A configuration, I've now added a new touchscreen component. Again, I'm using the platform of the XPT2046. I'm referencing the display up here, the main display that we defined before, so I'm telling it to use that display. I'm indicating the chip select pin, which we determined earlier during the Arduino testing. I have to provide calibration data, so where did I get these numbers? Well, initially I got those from the calibration routine we ran for Arduino. But here what I'm going to do, I'm actually going to put out the raw coordinates to the ESPHome log so I can figure out what those X and Y mins and maxes are, then I can update my calibration accordingly. With the new configuration flashed and the logs running, now what I'm going to do is I'm going to touch all four corners of the display. I'm going to do this in a corner multiple times, and you see that we're getting data coming back out into the logs, and that's a good sign. But what we're looking for right now, as we touch the four different corners, we're going to try to determine the max raw X and Y values. So I'm going to call that first corner A, this one B. Down here I'm going to call this corner C. Touch it a few times, try to get right in the very corners best we can. And then finally corner D up here in the top. So now I need to look through these data and try to pull out the raw values for the max X and the max Y. And we'll come back to the regular X, Y in just a minute. If we plot those values onto the four corners where we touched, we get something that looks like this. Now, for the calibration data, we're looking for the maximum and minimum X and Y values, and we can plop those into the configuration. But you notice that we've got another problem here. Down here at C, which is labeled XY00, these are the actual coordinates that we can use in our code. We actually need that to be over at A. So based on the orientation of our particular display, these coordinates are kind of messed up, but that's an easy fix. In the ESPHome configuration, we can add a transform section to swap and or mirror X and Y. Now, touch controllers generally have different coordinate systems represented by the raw values than the display on which they're used. The goal here is to have the reported coordinates for X and Y from touch align with the display size and orientation. So 0, 0 would be up here at the top left-hand corner, and we want X to run from 0 at the top left to approximately 480 horizontally, and Y to run from 0 down to 320 vertically. Do note that I've also updated my calibration numbers here, and you may have to repeat this process a few times to get the accuracy exactly where you want it. Okay, with those new values, we're going to check this again. And remember that this time we're looking at just the XY values, the coordinates that we will use in our code for things like automations. Before 0, 0 was down here in this corner, we want 0, 0 for X and Y to be up here in this corner. So we will touch this and see if we get something close to 0, 0 for X and Y value. There we go. We got X is 0 and Y is 2. And down here we ought to have X still being 0, but our Y value ought to be close to the maximum of 320. We touch that. There we are. X is 2 and Y is 319. This ought to be our maximum X and Y near 0. And there we go. Close to 480 and 0. And down here in this corner ought to be our maximum X and Y. There we go. Pretty close to 320 by 480, which is the dimensions of the board. So everything looks good in terms of touch, and our coordinates now match the resolution of the screen. So that pretty much takes care of this resistance touch, but now let's see if we can get capacitance touch working on Clone B. From my earlier work with the Arduino, I know that the Clone B uses a GT11 touch controller. So I simply went to ESPHome and searched for GT911, and up popped this page. Now note that it says we need I2C to be set up. Well, again, if we're using non-standard GPIO pins for that, we need to know what those are. But once again, I determined that during the work with Arduino, and we simply need an interrupt pin. Everything else comes from this base touchscreen component, which is the same configuration that we used for Clone A and the Resistive Touch. The difference is here, I don't believe we'll have any kind of calibration numbers. We'll copy this over to Clone B's ESP configuration, fire up the logs, and see what we get. Over here in my ESPHome configuration for my Clone B, you can see where I've added the I2C section. And since this board doesn't use the standard I2C pins, I do have to specify the data and the clock pins, which once again, if you want to know how I found those, I covered all that back in the Arduino section. Once I have the I2C defined, I can come down here and I can add my touchscreen. And this is very similar to Clone A, except notice I'm using the GT11 platform. I'm obviously specifying I2C address. The I2C, as you'll notice in the logs, will scan and find this, but if I add additional I2C devices down the road to those external JST connectors, I'm going to go ahead and put the address in here. I give it an ID, tell it to use the main display, tell it which I2C bus to use. Again, it's probably optional. Do notice here I've got the interrupt pin marked out. I, for some reason, could not get the board to respond with an interrupt pin. I'm guessing that by remarking this out, it's going to work in polling mode as opposed to interrupt mode, and it seems to work fine. And I've already done a little bit of testing to swap my XY. In this case, I did not need to mirror Y, and we're just going to again output the touch coordinates to the ESPHome log for now. Let me go ahead and flash this and we'll take a look at the logs. Okay, well, once again, keep an eye on the logs. If I've got the transform and the axes set right in our swap, this top corner should be 0, 0, or a minimum X and minimum Y. If I touch that, there you go. You got X is 1, Y is 0. Again, we don't really need to pay any attention to the calibration in this particular case, as the calibration seems to pretty much already align with the display. This should be my maximum X and minimum Y over here. Look at that. Yep, 475 versus 480. This should be maximum Y and minimum X. There we go, 320. It's got 319. This should be max X, max Y. And there we go. So even without putting any calibration numbers in there, now I could go back and add calibration if I want, but you can see they pretty much align. It's just I've had to swap X and Y here to get 0, 0 to align with my display orientation. So that's touch working now, also with the Capacitance Touch. And of course, one of the nice things about ESPHome is the native integration into Home Assistant. As soon as I flashed ESPHome to a board and it came online, a new device was discovered in Home Assistant. Once I add these through a simple button click, all the entities from my ESPHome configuration will then be available in Home Assistant to use on dashboards or in automations and scripts. And I should also mention, just like with Arduino, the LVGL graphics package is also available in ESPHome for creating interactive widgets on your display. It took way longer than it should have, but I now successfully got both the display and touch features working on the two different clones with different touch technologies using both Arduino and ESPHome. The amount of time really isn't the fault of either the Arduino library authors nor the ESPHome documentation, especially with the new website design. A huge thumbs up from those involved with that much needed upgrade, but it's really the fault of the board sellers who often fail to provide specific documentation for the product they're selling, or in my case with Clone B, even incorrect documentation. So while this video is specifically focused on two different clones of the cheap yellow display, a lot of what I've shown could be applied to clones of other types of components. You may find a lot of mass-produced clones or similar-looking devices, but they have significant differences. So you always need to identify things like the chips used, the GPIO pins, and other things like I2C addresses for any components that you want to use, whether that be in Arduino or ESPHome. Hopefully I provided a few tips for how to do that with not only the cheap yellow display, but with clones of other types of components as well. I'll be back soon, and you'll probably see more about the cheap yellow display when I do get to the larger project, but until that time, I'd like to say thank you for watching, and I hope to see you again soon.